We are going to look at how to apply Newton's law for solving problems on inclined plane. So we are going to apply Newton's law, and hence we have to recap what we did in the previous class. So let's just quickly do that.
Okay, in this slide we see two pictures. The first one shows that there is a coin on top of a piece of paper which is on top of a glass tumbler. The second one shows that the paper flies off when a person hits the paper, whereas the coin falls down. So the problem is asking you, or the question is asking you, why does the coin fall in the glass instead of moving away with the paper? So we can apply Newton's first law, which says that an object which is at rest stays at rest unless an unbalanced force acts on it, and therefore the force is being applied on the paper, and therefore the paper flies off, whereas the coin, which was in a state of rest, falls down into the tumbler.
Now let's look at this one. Here it's asking, is this statement about Newton's second law true or false? There's one important point or important word which is missing from here, and that's net force. Whenever we apply Newton's second law, we have to say that the net force is equal to mass multiplied by acceleration. Net force can also be called as the total force which is acting on the object, because we might have more than one force acting on the object. So we can write this equation in symbol forms as sigma F equal to m multiplied by A, where sigma F is the net force. Now let's check this one. It says that draw a free body diagram. Again, this is based on our previous knowledge. We did this before. There's a body which is at rest on horizontal surface, and it's asking you draw the free body diagram for this. So let's say that let me label two forces. Let's name them as A and B. So you need to tell what are these forces A and B. So we can see that force A is the normal force. This is the normal force. And force B is the force of gravity. Let's try another situation. So here we have got an object which is placed on inclined plane, and we need to draw the free body diagram for this. So again, I will label the forces and you might try answering it. So what do you think these three forces A, B and C would be? Remember, it doesn't say what kind of ramp it is. Is it rough or smooth? As long as they do not mention it smooth, we have to take the force of friction as well. So we can see that here we have got force A as the normal force, force B is the force of gravity, and force C is the force of friction. The other two forces which are shown on the diagram, they are the components. We'll come to that a little later. But just to remind you, how do we get the force of friction? We know that the object is expected to move down, and friction force is a force which opposes the motion of the object. So it will act upwards. And that's how it is shown in the diagram. Now for W, for the force W, we are having, or the force of gravity, we are having two components. Why do we have two components for gravity? Because force of gravity is making an angle 12 degrees with the perpendicular to the inclined plane. Okay.
Let's try to quickly understand what I said in a separate diagram. So let's say we have an inclined plane and we have an object on the inclined plane. Now because there are multiple forces, we may have to resolve them to get them along the x and y axis. So for an inclined plane, the x axis is along the plane and the y axis is perpendicular to the plane. So that's your x axis here and y axis here. So in this particular diagram, we have got W, okay, and this W is making an angle of 12 degrees with the y axis, and hence we can see that it has got W cos 12 along the y axis. The component along the y axis is W cos 12, and the component along the x axis is W sin 12. Also look at the arrows. The arrows of the components are downwards, yeah, pointing away from the object, just like the vector W itself. So just to quickly recap about the components, if the axis makes the angle, for example in this case the y axis is making the angle 12, the axis makes the angle, then it is going to get cos component, and the axis which does not make the angle, there is no angle given here, and that is going to get the sine component.
Now, till now we just recapped what we did from before, as it is very important to know all the concepts which we just now covered to, to, to apply to our objective, that is to analyze the motion, that is calculating acceleration and unknown forces for an object based on smooth inclined plane using Newton's law. So we are going to take a problem and see how we can solve this problem based on Newton's law. So there is a 2 kg block on an incline at 60-degree angle which is held in equilibrium. So this word equilibrium is important. What does that mean? It is not moving up or down. It is just at rest on the on the inclined plane. And it is kept in rest or kept in equilibrium with the help of an horizontal force. We can see that there is a force F which is acting horizontal and which is keeping the object in equilibrium. Problem is asking calculate the magnitude of horizontal force. It says disregard friction, so we don't have to draw friction. And in part 2 it's asking determine the magnitude of normal force on the block. So our first step will be to draw the free body diagram. So we have to draw all the forces on the object. So we'll have a force of gravity as usual. We'll have a force applied by the surface, which is a normal force. Because we are disregarding the friction, there is no frictional force required in the free body diagram. Now we can see that we have to get the x and y axis. So I'm drawing dotted lines to show where is the x and y axis. So this is our x axis and this is our y axis. Now we can see that the angle which is being formed by the weight with the y-axis is 60 degrees, and hence we are going to find the components of W, which will be W cosine 60, and this side it will be W sine 60. We can also see that the horizontal force is not along the x-axis or y-axis, so we need to resolve that as well. Okay, So we are going to write the angle which the horizontal force is making. So you can see this angle will also be 60 degrees because it's a horizontal force. So it will be parallel, and alternate angles for parallel lines are equal. This is our knowledge from mathematics. So we are going to use that. Now, so horizontal force is making an angle of 60 degree, and we need to resolve the horizontal force along the x and y axis. So we are going to write f cosine 60 along the x axis and f sine 60 along the y axis. Look at the arrow, the direction of the arrow, how it is pointed. It will follow the same direction as the force itself. So you can see that horizontal force is towards the object. So both the components are also towards the object. Now let's look at it a little more clearly. Here the force W has been replaced by 20 because it says that 2 kg block. So W we know that's given by mg. So that will be 2 multiplied by g, which is 10. So that will be equal to 20 Newton. And hence we are replacing W by 20. So we have got 20 is the weight of the object, 20 cosine 60, 20 sine 60. These are the components of the weight. And for the force, we have got F cosine 60 and F sine 60. Now our free body diagram is ready. Now let's see how to solve for the normal force which was being asked in the problem, and for the horizontal force F. There are two unknowns, so we need to find them. So we are going to write the Newton's law, sigma F equal to ma. We are going to write it for along the plane and we are going to write it for perpendicular to the plane. So we are going to create two equations, one along the plane and one perpendicular to the plane. So let's write that. So along the plane, we are going to write sigma F equal to ma, and we'll check what are the forces along the plane. We have got F cosine 60, 20 sine 60. 20 sine 60 is downwards along the positive x-axis. F cosine 60 is upwards along the negative x-axis. So we are going to write with the signs 20 sine 60 minus F cosine 60 equal the mass, which is 2, multiplied by acceleration, which is 0, because the object is not moving. So 20 sine 60 is equal to F cosine 60. Okay. And here we are just solving it using our mathematical tricks. So we can write this as 20 tan, sine over cos is tan, 20 tan 60. So tan 60, the value is root 3. So we can write 20 root 3 Newton. It is 20 root. Now let's do the same thing perpendicular to the plane. So we are going to write first the Newton's law, sigma F equal to ma. Again, the object is in equilibrium, so it's not moving up and down. Therefore, the acceleration will be 0. Let's check what are the forces. F sine 60 downwards, Fn normal force upwards, 20 cos 60 downwards. So we have to write them with their signs. So we'll write Fn, which is upwards, minus F sine 60 minus 20 cosine 60 equal 2 multiplied by 0, because acceleration is 0. So this becomes equal to 0. So we have got an equation here to solve. So Fn minus, now F we know from the previous slide. So we are going to put the value that 20 root 3. Sine 60, the value of sine 60 is root 3 over 2 minus 20. Cosine 60, the value is half, equal to 0. So we can solve this. Fn minus 20 into 3, root 3 into root 3 is 3 over 2 minus 20 into half is 10, equal to 0, which we can further solve, and we can get Fn as 30 plus 10. So 20 into root 3, this part, 20 into 3 over 2 will become 10 into 3, which will be 30, and this is 10, which goes on the other side. And this will be equal to 40 Newton. So we have solved for Fn, which is the normal force, and we have solved for F, which was the horizontal force. Now we have got another problem of the same kind. Let's read it. It says that a 5.4 kg bag is on incline with an angle theta equal to 15 degrees. Find the magnitude of the normal force on the bag and find the magnitude of acceleration of the bag. So first you need to think about the forces which will be acting on this bag which is kept on the inclined plane. So we'll have weight acting vertically downwards. We'll have Fn, and then we need to think, is the inclined smooth or rough, because they do not say anything about whether it is rough or smooth. So we have to take it as rough, and then we have to predict its motion, how the object would be moving. So the object is expected to move downwards. So the object is expected to move downwards. That means the friction will be acting upwards. So we have got the three forces. Then we need to check whether they are along the x and y axis. So x axis is along the plane, y axis is perpendicular to the plane. So we have got one force which is not along the x or y axis, and that's the weight. So we need to resolve that. So we will resolve the weight force. Perpendicular to the plane, it will be W cosine 15, and parallel to the plane, it will be W sine 15. So we can create the equations for this along the plane and perpendicular to the plane. Along the plane, sigma F equal to ma. So we'll write W sine 15 minus the friction force equal 5.4 multiplied by A.
Perpendicular to the plane, perpendicular to the plane. Again we can write sigma F equal to ma. Now perpendicular to the plane, the object is not moving, so there will be no acceleration. It is only expected to move along the plane and not perpendicular to the plane. So perpendicular to the plane, we'll write Fn which is upwards, minus W cosine 15, which is downwards, equal 0. Why 0? Because acceleration is 0 along perpendicular to the plane. Now we can solve these two equations to get the values of unknown. Along with this, we might also have to use the fact that friction is given as mu Fn. Now this also we know from before. So we might have to use this also to solve for the unknowns. So you can solve it and find out what are the magnitudes of normal force and of the acceleration of the bag. Because getting the equation is the major part, and solving the equation is a mathematical tool which we can apply and get the values of unknown.